Given the string, check if it is a palindrome. We've been working through the CodeSignal Arcade, and so next up is number 3 of the intro, check palindrome. So the question tells us a palindrome is any string that doesn't change when reversed, so it reads the same forward and back. It gives us examples like I, noon, race cars. I think race cars is not a palindrome, but race car by itself is. So we'll cover a couple different approaches and try and learn something along the way about Python. The first way I want to solve it is just with 2 pointers. So the way you can think about this 2-pointer solution is we can have one pointer at one side of the word and another pointer at the right. So I'm calling these left and right pointers. And we basically want to read the word from the left and the right side. So how would a human read the word left to right? They would just go letter by letter, sound it out. This is elementary school. And read the word. Then you go start from right to left and read the word. Obviously the English language isn't designed like that, but you can imagine how this would work. In this example, it reads the same forward and back, race car. So programmatically, we can just make this happen at the same time. So as the left and right, we can just see if it's the same letter. In this case, they're both R's, and then move them each closer to the center. They're both A's, move them closer to the center. They're both C's, move them closer to the center. And at this point, we actually don't even need to check, because if they're the same index, they have no choice but to be the same letter. And then you can see with an example that doesn't work, if you just start left and right, if they're not the same, we can just instantly return false. So let's go ahead and program up this 2-pointer solution. We'll start with setting our pointers. Left will start at the leftmost index, which is always going to be 0. And right will be at the rightmost, which will always be the length of the string minus 1. Then we can just check while left is less than right. So we don't even need to check if they're equal, because if they're equal, they're always going to have the same letter. And we can just say if the input string at the left index is not the same as the input string at the right index, instantly return false. Otherwise, add 1 to the left to move it closer to the right side, and then subtract 1 from the right to move it closer to the left side. And then when they overlap each other or meet in the middle somewhere, then we know that, at this point we can just return true, because once they overlap, you've checked everything you need to check. If you can think of the word as like a mirror image of each other. You can think of the 2 halves of the string as like a mirror image of each other. So we can submit this solution and it passes. That's great. Now I'll show you a one-liner Python solution. So you may have seen this meme before about how in different languages you can treat strings as just arrays of characters, and in Python, strings are arrays of characters. In C++, apparently it works that way, but Java, they're like their own thing. So obviously a string in Python and a list of characters in Python is not the exact same thing, but it is kind of conceptually helpful to think about it like that. So if you look at the documentation, what they actually do have in common is that they're both sequences. So a sequence is anything that stores data in an ordered way. And as you can see here, text strings are an example of a sequence. And one of the operations you can do on any sequences in Python is slicing. So all of that is basically me trying to justify why this solution here works. We're taking the input string and comparing it to the input string reversed. So this is by far the cleanest looking, most satisfying Python solution. Basically all the solutions list just shows this in variations of different languages. This is doing the same thing in JavaScript, just reversing the string. In Python, it just looks a little bit nicer. So I guess what did we learn here? We learned that strings and lists are both sequences in Python, and that's why they both have this operation. Other than that, we saw an example of using a 2-pointer solution to take on this pretty easy problem. So hopefully this is helpful, and I'll see you in the next video.